Welcome to Physical Science's Consultorium. This video is part of the series Misconceptions About Space, where we examine ideas that feel intuitive but quietly fail when physics is applied. In this episode, we ask a familiar question: are black holes cosmic vacuum cleaners? Black holes are often imagined as objects that constantly suck in everything around them: stars, planets, even entire galaxies. Nothing escapes. Everything nearby is pulled inward. This image is widespread, dramatic, and deeply misleading. The intuition feels reasonable. The word hole suggests emptiness. The word black suggests disappearance. Popular visuals show violent spirals of matter being swallowed. Together, they create the impression of suction, as if black holes actively pull the universe toward them. But a vacuum cleaner works by pulling air inward using pressure differences. It actively drags matter from its surroundings. Gravity does not work this way. There is no suction involved. Gravity is simply an attractive interaction between masses. Its strength depends on how massive an object is and how far away you are from it. It weakens rapidly with distance. It does not reach out indefinitely to pull everything in. Black holes obey these same rules. Far from a black hole, gravity behaves normally. If the Sun were suddenly replaced by a black hole of the same mass, Earth's orbit would remain essentially unchanged. There would be no sudden inward pull. Nothing would be sucked in. Distance matters. At large distances, a black hole's gravitational influence is no stronger than that of any other object with the same mass. The extreme behavior associated with black holes is not long range. Objects do not fall into black holes automatically. For matter to be captured, it must lose energy and angular momentum. Most objects either orbit stably or pass by without being affected in any dramatic way. Gravity alone does not guarantee capture. Some matter does fall in, but not because of suction. Gas and dust can collide, heat up, and lose energy through friction. This process forms an accretion disk. The intense radiation we observe comes from this heated matter before it crosses the event horizon, not from matter being pulled in from afar. The truly extreme effects occur only very close to the black hole. Near the event horizon, tidal forces become enormous. But this region is extremely small compared to the vast distances of space. Scale is the key. Black holes are dramatic only at close range. From far away, they behave like ordinary massive objects. Their fearsome reputation comes from confusing local extremes with long-range influence. There are things we can describe with confidence. We can predict how matter moves toward a black hole, how it heats up, how it emits radiation, and how gravity behaves outside the event horizon. These predictions are testable and observed. But there is a clear boundary. Once matter crosses the event horizon, no signal can reach us. At that point, direct observation ends. Science does not claim detailed knowledge of what happens inside a black hole. Those regions are not accessible to observation. Speculation is not treated as established understanding. Recognizing this limit is part of scientific rigor. Instead of inventing stories, astronomy focuses on what can be tested and constrained. This discipline protects understanding from myth. From the outside, a black hole is completely described by a small set of properties: its mass, its rotation, and its charge. These are sufficient to predict its external behavior. So the correct mental picture is not a cosmic vacuum cleaner. A black hole does not sweep up the universe. It does not pull everything toward it. Black holes are dangerous only if you get very close. From far away, they obey the same gravitational laws as other massive objects. There is no suction, and no universal swallowing. If this way of understanding space science is useful to you, this is exactly what Physical Science's Consultorium exists for. In this series, we examine familiar ideas and quietly correct them using physics. If you found this episode helpful, please like, share, and subscribe to the PSC channel.